From up here, our planet looks perfect. It's only when we look more closely that we start to see some of the results of our consumption.
Air pollution, climate change, and ozone depletion. Good day, everyone. This is the title of our report, and these are the subtopics that we will be discussing. First is the nature of the atmosphere, would be discussed by Christine Paca, followed by the major outdoor air pollutants to be shared to us by April Joy Ipis, indoor air pollutants by Mr. Norby Tubat, and lastly, but definitely not the least, the laws and regulations to reduce outdoor and air pollution that will be discussed by yours truly, Gabriel Javinas.
Air pollution consists of chemicals or particles in the atmosphere that pose serious health and environmental threats. But what causes air pollution, and what does it mean for our planet? Some air pollution comes from natural sources like volcanic eruptions, wildfires, or allergens.
Under a thin blanket of gases surrounding in the Earth, called the atmosphere. It is divided into several superficial layers. About 75 to 80% of Earth's air mass is found in the troposphere, the atmospheric layer closer to the Earth's surface. This layer extends about 17 kilometers or 11 miles above sea level of the equator and 6 kilometers or 4 miles above sea level over the poles. If the Earth were the size of an apple, this lower layer containing the air we breathe would be no thicker than the apple skin. Take a deep breath. About 99% of volume of air you inhale consists of two gases, nitrogen 78% and oxygen 21%. The remaining is 0.93% argon, 0.040% carbon dioxide, and small amount of water vapor, varying from the equator to the poles, dust and the soot particles, and other gases including methane, ozone, and nitrous oxide. The atmospheric second layer is the stratosphere, which extends from about 7 to about 48 kilometers, from 11 to 30 miles above the Earth's surface. Although the stratosphere contains less matter than the troposphere, its composition is similar, with two notable exemptions. Its volume of water vapor is about 1,000, and the troposphere and its concentration of ozone is much higher. Much of the atmosphere's small amount of ozone is concentrated in its portion of stratosphere called ozone layer, found roughly 17 to 26 kilometers above sea level. Most stratospheric ozone is produced when some of the oxygen molecules in the layer interact with ultraviolet radiation emitted by the sun. The UV filtering effect of ozone is the lower stratosphere act as a global sunscreen that keeps about 95% of the sun harmful UV radiation UV radiation from reaching the Earth's surface. It allows us and other life forms to exist on land and help to protect us from sunburn, skin and eye cancer, cataract, and damage to our immune systems. It also prevents much of the oxygen in the troposphere from being converted to photochemical ozone, a harmful air pollutant when found near the ground. The stratospheric ozone layer is a vital part of Earth's natural capital that helps to keep us from other species alive, allow us to live on land, and supports our economies. The second part of my report is titled What are the major air pollution problems? Air pollution came from natural and human sources. Air pollution is the presence of chemical in the atmospheric in concentrations high enough to harm organisms, ecosystem, or human-made materials, or to alter climate. Almost any chemical in the atmosphere can become a pollutant if it occurs in a high enough concentration. The effect of pollution range from annoying to lethal. Air pollutant came from natural and human sources. Natural sources include windblown dust, pollutants from wildfire and volcanic eruptions. The volatile organic chemicals released by some plants, most natural air pollutants, are spread out over the globe and diluted or are removed by chemical cycles. Precipitation and gravity. But in area experiencing volcanic eruption or forest fires, chemical emitted by these sources can temporarily reach harmful levels. Most human inputs of outdoor air pollutants occur in industrialized and urban areas where people, cars, and factories are encountered. These pollutants are generated mostly by the burning of fossil fuels in power plants and industrial facilities, and in motor vehicles. Cigarette smoke and chemical used in building materials and cleaning products, processes and human activities are concentrations high enough to cause harm while the atmosphere. Some primary pollutants react with one another and with other natural components of air to form new harmful chemical called secondary pollutants. Outdoor air pollution was once a regional problem limited mostly to cities. Now it is a global problem, due to sheer volume of pollutants produced by human activities. Prevailing winds can spread long-lived pollutants entering atmosphere from India and China across the Pacific where they affect air pollution levels on the west coast of North America. There is no place on the planet's surface that has not been affected by air pollution from human activities. Over the past 40 years, The quality of the outdoor air in most of the more developed countries has improved greatly. This has occurred primarily because grassroots pressure from citizens, especially during 1970s, led government in United States and most European countries to pass and enforce air pollution control law. On the other hand, according to the World Health Organization, more than 1.1 billion people live in urban areas where outdoor air is unhealthy to breathe. Most of them live in densely polluted cities and less developed countries where air pollution control laws do not exist or are poorly enforced. That will be my report for today. Thank you, everyone.
The next topic is major outdoor air pollutants, and these are carbon oxides, nitrogen oxides and nitric acid, sulfur dioxide and sulfuric acid, particulates, ozone, and volatile organic compounds. Carbon monoxide or CO is a colorless, odorless, and highly toxic gas that forms during the incomplete combustion of carbon-containing materials. The major sources are motor vehicle exhaust, the burning of forests and grasslands, the smokestacks of fossil fuel burning power plants and industries, tobacco smoke, open fires, and inefficient stove used for cooking or heating. Carbon oxides or CO can cause headache, nausea, drowsiness, confusion, collapse, coma, and death. The next major outdoor air pollutant is nitric oxide or NO. It's a colorless gas that forms when nitrogen and oxygen gases react under high combustion temperature in automobile engines and coal-burning power and industrial plants. At high enough levels, nitrogen oxides can irritate the eyes, nose, and throat, aggravate lung ailments such as asthma and bronchitis, suppress plant growth, and reduce visibility when they are converted to nitric acid and nitrate salts. Sulfur dioxide is a colorless gas with an irritating odor. About 1/3 of the sulfur dioxide in the atmosphere comes from natural sources such as volcanoes. The other 2/3 and as much as 90% in some urban areas come from human sources, mostly combustion of sulfur containing coal in power and its industrial plants, oil refining, and the smelting of sulfide ores. Sulfur dioxide can damage crops, trees, soils, and aquatic life in lakes, and they corrode metals and damage paint, paper, leather, and the stone used to build walls, statues, and monuments. The next major outdoor air pollutant is suspended particulate matter. It consists of a variety of solid particles and liquid droplets that are small and light enough to remain suspended in the air for a long period. About 62% of the SPM in outdoor air comes from natural sources such as dust, wildfires, and sea salt. The remaining 38% comes from human sources such as coal burning, power, and industrial plants, motor vehicles, wind erosion, and exposed topsoil and road construction. These particles can irritate the nose and throat, damage the lungs, aggravate asthma and bronchitis, and shorten lifespan. The next major outdoor air pollutants is ozone. It is one of the major ingredients of photochemical smog. It is a colorless and highly reactive gas. It can cause coughing and breathing problems, aggravate lungs and heart diseases, reduce resistance to colds and pneumonia, and irritate the eyes, nose, and throat. It also damages plants, rubber in tires, fabrics, and paints. The last major outdoor air pollutants is organic compounds that exist as gases in the atmosphere or that evaporate from sources on Earth into the atmosphere are called volatile organic compounds.
Smog is a type of air pollution that reduces visibility and has serious health effects. Smog can be divided into two categories: sulfurous and photochemical. Sulfurous smog is made up of chemical compounds called sulfur oxides. It occurs when burning sulfur-bearing fossil fuels such as coal. Photochemical smog, also called ground-level ozone, is a result of the reaction between sunlight, nitrogen oxides, and volatile organic compounds. Nitrogen oxides come from car exhaust, coal power plants, and factory emissions. Volatile organic compounds are released from gasoline, paints, and many cleaning solvents. Smog not only creates a brown haze that reduces visibility, but also harms plants, irritates the eyes, and causes respiratory distress.
There are several factors can decrease or increase outdoor air pollution. There are 5 natural factors help reduce outdoor air pollution. First, particles heavier than air settles out as a result of gravitational attraction to the Earth. Second, rain and snow partially cleanse the air of pollutants. Third, salty sea spray from the oceans washes out many pollutants from air that flows from land over the oceans. Fourth, winds sweep pollutants away and dilute them by mixing them with cleaner air. Fifth, some pollutants are removed by chemical reaction. There are 6 factors can increase outdoor air pollution. First, urban buildings slow wind speed and reduce dilution and removal of pollutants. Second, hills and mountains reduce the flow of air in valleys below them and allow pollutant levels to build up at ground level. Third, high temperatures promote the chemical reactions leading to the formation of photochemical smog. Fourth, emission of volatile compounds from certain trees and plants in urban areas can promote the formation of photochemical smog. Fifth, the so-called grasshopper effect occurs when air pollutants are transported at high altitudes by evaporation and winds from tropical and temperate areas through the atmosphere to the Earth's polar areas as part of the Earth's global air circulation system. Lastly, the 6th factor has to do with the vertical movement of air. During daylight, the sun warms the air near the Earth's surface. Normally, this warm air and most of the pollutants it contains rise to mix with the cooler air above and disperse.
Hello guys, good day. And now let's proceed to the indoor air pollution. According to Rosalie Carter, there is nothing more important than a good, safe, and secure home. It is believed that a house is the most secure and healthy environment for any individual. However, the house can also be a source of various air pollution or air pollutant that can have a significant adverse impact on health. According to the latest report of the WHO, which is the World Health Organization, 8 million people die every year globally because of air pollution. Among these, 4.3 million die because of air pollution from household sources. and 3.7 million die because of ambient air pollution. That is according to the WHO report. And now, let me discuss to you a sort of discussion about the indoor air pollution. As you can see in the slide, indoor air pollution is a serious problem. Yes, it is actually a serious problem, especially in our family. Indoor air pollution, when we talk indoor air pollution, it is caused by burning solid fuel sources such as firewood, crop, waste, and dung for cooking and heating. The burning of such fuels, particularly in poor households, result in air pollution that leads to respiratory diseases which can result in premature death. The WHO calls indoor air pollution the world's largest single environmental health risk. That is according to the World Health Organization. As we know, indoor air pollution is a risk factor for several of the world's leading causes of death, including heart diseases, pneumonia, stroke, diabetes, and lung cancer. According to the Global Burden of Disease study, 1.6 million people died prematurely in 2017 as a result of indoor air pollution. That is how dangerous is the indoor pollution. It could not be seen in our naked eye, but it can be found in our place at home, especially at home. To put this into context, this was 4 times the number of homicide, close to 400,000 in 2017. That is how dangerous is the indoor air pollution. As you can see, I have here a illustration which we can identify where we can find the so-called indoor air pollution. Numerous forms of indoor air pollution are possible in the modern home. Yes, air pollutant levels in the home increase if not enough outdoor air is brought in to dilute emission from indoor sources and to carry indoor air pollutants out of the home. In addition, high temperature and humidity levels can increase the concentrations of some pollutants. Indoor pollutant can be placed into 2 groups, biologic and chemical. So as you can see the illustration, indoor air pollution can be found in our home. That is how the illustration show. And the chemical released from the building of furnishing materials, the pets, especially the pets, animals, carbon monoxide and other gases from cooking foods. Those products use liquefied petroleum gases, combustions of gases, cigarettes, and outdoor air pollutant. Now, we all face a variety of risks to our health as we go about our day-to-day lives. Driving in cars, flying in airplanes, engaging in recreational activities, and being exposed to environmental pollutants all pose varying degrees of risk. Some of risk are simply unavoidable. Some we choose to accept because to do otherwise would restrict our ability to lead our lives the way we want. Some are risks we might decide to avoid if we had the opportunity to make informed choices. Indoor air pollution and exposure to hazardous substances in the home are risks we can do something about. In the last several years, a growing body of scientific evidence has indicated that the air within homes and other buildings can be more seriously polluted than the other air in even the largest and most industrialized cities. Other research indicates that people spend approximately 90% of their time indoors. So imagine 90% of their time indoors. Thus, for many people, the risk to health from exposure to indoor air pollution may be greater than risk from outdoor pollution. So it's meant to say, don't just stay at home, just enjoy life, move. But nowadays, since we are facing a pandemic, so almost 80% of the people will stay at home because some workers maybe has a what we call a work from home. They work from home, so they are staying at home in order to prevent the pandemic or the what we call the COVID-19. So in these cases, we are prone to this indoor pollution because we are staying at home. Yes. In addition, people exposed to indoor air pollutant for the longest period are often those most susceptible to their effect. Such groups includes the young, the elderly, and the chronically ill, especially those suffering from respiratory or cardiovascular diseases. So it comes to my mind that if indoor pollution is totally harm, well, of course, nowadays people will encounter that kind of pollution because most of the people staying at home because of the pandemic, right? So let's move on to ways to reduce indoor air pollutions. But we have we cannot control it, but we can reduce indoor air pollution. In what way? Now, I am going to share with you to how to reduce indoor air pollution. First is, of course, open your windows. Do not close always. Open, always open, in order to eradicate what we call, in order to smooth flow the ventilation. Adequate ventilation is key to promoting healthy indoor air, and opening windows. Pollen count isn't too high. Opening windows is an easy way to encourage a good change of indoor and outdoor air. Yes, that's the first one. Then second one is ban smoking. So you must not make your home as a smoking area. Yes. According to the Environmental Protection Agency, second-hand smoke impairs respiratory health and is responsible for about 3,000 lung cancer deaths per year in non-smokers. Then the third one is give your pets a bath. You need to take care of your, if you have pets at home, you need to take care of it. Make sure that it is totally clean, or if you have pets, bath them and wash their breathing often to reduce allergies causing danger. And we hate to break it to you, but you should also keep them out of the bedroom. So some people they let their pets stay in the bedroom and hug, so you must avoid that. You must be aware of that. The fourth one is use exhaust fans. Run fans in the kitchen to remove cooking fumes and in bathrooms to remove steam. Also be sure that your dryer vents to the outside to minimize length to reduce the level of pollen in the air. On days it's not possible to open the window, run your window air conditioner on the fans sitting with rain filter. Then the fifth one is put down a doormat. Wiping shoes can reduce pollutant carried into the house. So the indoor or the entrance and the exits, you must put a doormat where, or doormat just must be placed in a proper place. The sixth is change filters. If you have a forced air heating and cooling system, change the air filters more often when there's more smoke or pollen in the air. Change the filters. Don't cover up odors. Avoid air fresheners, scented candles, incense, and other odor masking fragrances which can trigger asthma. So we must avoid that things in order to prevent indoor pollution, because it's better to prevent than cure. The 8 is don't cover 9 is vacuum a fan. Do this especially if you have a pet. Brooms can just stir up more dust, so you must be responsible enough. You must make sure that the surroundings you clean the surroundings. 10 is use microfiber dusting clothes. It will capture more dust than cotton rags if you have. 11 is minimize carpeting. It can trap pollutants such as dust, mites, pet danger, mold spores, and other dirt and dust. Choose hard surface flooring instead. 12 is try to stay dry. Reduce mold. Keep moisture down by using a dehumidifier and cleaning the filter regularly. Third is store chemical safety. You must separate the chemical safety. Store solvent, glue, and pesticides away from living areas so that it could not be the chemical will not be exposed in air. 14. Try an air purifier. An air purifier alone won't remove all the impurities in your indoor air, but if you have gone to the effort to keep allergens and the other pollutant out of your home, an air purifier would help to reduce them further and certainly won't hurt and may even be of some benefit. That is how you can prevent the indoor or minimize the indoor pollution at home.
The last topic is the laws and regulations of outdoor and indoor pollution. The United States provide an excellent example of how a regulatory approach can reduce air pollution. The U.S. Congress passed the Clean Air Act in 1970, 1977, and 1990. With these laws, the federal government established air pollution regulations for key outdoor air pollutants that are enforced by states and major cities. Congress directed the EPA to establish air quality standards for 6 major outdoor pollutants. These 6 are the carbon monoxide, nitrogen dioxide, sulfur dioxide, suspended particulate matter or the SPM smaller than PM10, ozone, and lead. Each standard specifies the maximum allowable level for a pollutant average over a specific period. The EPA has also established national emission standards for more than 188 hazardous air pollutants or HAPs that are thought to contribute serious health and ecological problems. Solutions in reducing outdoor air pollution. There are ways to prevent and control air pollution from coal-burning facilities. Electrostatic precipitator are used to attract negatively charged particles in a smokestack into a collector. Wet scrubber, fine mist of water vapor trapped particulates and convert them into a sludge that is collected and disposed of usually in a landfill. Last is the baghouse filter. Air passes through fabrics that can remove almost 100% of PM emissions. Other solutions for outdoor and indoor air pollution. Outdoor, improved energy efficiency to reduce fossil fuel use. Rely more on lower polluting natural gas. Rely more on renewable energy, especially solar cells, wind and solar produced hydrogen. Transfer energy efficiency, renewable energy, and pollution prevention technologies to developing countries. For the indoor, reduce poverty, distribute cheap and efficient cook stoves or solar cookers to poor families in developing countries. Reduce or ban indoor smoking. Develop simple and cheap tests for indoor pollutants such as particulates, radon, and formaldehyde. Another example for indoor air pollution prevention and cleanup prevention: cover ceiling tiles and lining of air conditioning ducts to prevent release of mineral fibers. Ban smoking or limit it to well-ventilated areas. Set stricter formaldehyde emission standards for carpet, furniture, and building materials. Prevent radon infiltration. Use of office machines in well-ventilated areas. Use less polluting substitutes for harmful cleaning agents, paints, and other products. For cleaning up, use adjustable fresh air vents for workspaces. Increase intake of outside air. Change air more frequently. Circulate buildings' air through rooftop greenhouses. Use exhaust hoods for stoves and appliances for burning natural gas. Install efficient chimneys for wood-burning stoves.
While air pollution has many consequences for our planet, there are solutions. we can limit toxic pollutants, smog, and greenhouse gases by decreasing the use of fossil fuels, such as in transportation, manufacturing, and electricity generation. Reducing air pollution not only contributes to a cleaner environment and better human health, but can also slow the rate of global warming.